Good morning. Today we have an evacuation drill, so I'm just putting all of this on a video. We're moving into integrals, so I wanted to give you a quick overview of what I'm thinking. I wrote down the order I think that we'll go in. So we're going to start with definite integrals and properties of integrals. Then we'll move into Riemann sums tomorrow. We'll do our beginning antiderivatives, and then we'll start some strategies for how to take antiderivatives, rewriting them, using substitution, and trying something called tricky substitution. Somewhere in there I'm going to throw in the fundamental theorem of calculus, and I'll explain that later. We're going to do integration by parts. It's a method that you've never done before. Yay! This is a strictly BC strategy. And integration by partial fractions, which is another strictly BC strategy, so that's kind of awesome. Then we'll move into separable differential equations and take a test. This is what I'm hoping we get through before Thanksgiving. We'll see, maybe even before then. I'm not sure how fast we'll be able to go. So we'll have a test. This will be in the second marking period, though. I can't imagine there's going to be one before that. Then we'll go into our area and volume. I've had this set up, not great. I didn't bring my little thingy today. We'll go into area and volume, and then we'll have a test on all integration. And this will maybe be like an A-B test. This will be before the winter break. And it'll be on everything A-B. And yeah, it'll be the same. Well, I don't know. I haven't even thought about, maybe it'll be 200 points, but I'm not really sure. I don't know how to handle that yet. People were asking about, so this is a lot of material to do before another test. So I will probably throw a quiz in here somewhere on integration, but that's the basic gist of what we're going to try to get through within the next month to month and a half. All of it being review until we get up to here. And then we've done area and volume last year when we were remote, but remember they didn't put it on the A-B test. So how well do we really remember? I don't know, we'll have to see. And then there's also a new method that you've never done that's only a BC strategy. So for this week, we have class every day, woohoo! So we're gonna be doing something every day. Next week, you're gonna basically be off because we have Monday and Wednesday are day 2s anyway, and we have this wellness thing going on. Tuesday is a full remote day for everybody. So next week you'll have something. It'll probably be an AP classroom assignment of reviewing however much we get through this week. Okay, so a really quick reminder on what a definite integral is and what the properties of definite integrals are. So hopefully today is really just a pretty simple review for you and you don't feel too confused. So a definite integral, here's our integral symbol, is an integral that goes from somewhere to somewhere. So let's say from 2 to 5. And we take the integral of a function with respect to x. That's what all that means. For today, the only way we're going to talk about definite integrals is by looking at the area under a curve. So when we look at a definite integral, the way we're going to think about it for now is, what's the area under the curve f of x from 2 to 5? So let's say I have a picture, and let's just say I have a horizontal line, and it's up here at 3. So if I'm asked for the integral of f of x from 2 to 5, I'm literally just taking the area from 2 to 5 under the curve f of x, and we'll say that this horizontal line is f of x. So I'm taking the area. I'm just being asked, what's the area under there? So this is a rectangle. It's 3 by 3, so the area is 9 of that rectangle. That's a definite integral. The only things we can do definite integrals for now, at least for today, are things that we know the area under. So I can take the definite integral under a triangle. I can find the definite integral of a trapezoid. Area of a trapezoid is 1/2 times the height times the bases added up. Bases are these two parts. They're the two parallel parts, and the height is this. When you're looking at your trapezoid, I can also take the area under semicircles. So as long as I know how big the radius is, let's say this, my center is here, my radius is 2, then I can take this integral as well. Pi r squared, if it's half a circle, divided by 2. Oh gosh, the light just went out, hold on. Okay, so try that first Khan Academy assignment, which is finding the definite integral using area. Then pause, come back to this, and let's talk about properties of definite integrals. So, properties of definite integrals. This is a great way to do notes, but here we go. There are properties to this. For example, the biggest thing to know is that when I have area above the x-axis, when I have area above the x-axis, it is considered positive as long as I'm reading my definite integral from left to right. When I have space under the x-axis, that area is considered negative as long as I'm reading from left to right. If I'm moving from right to left, all of that changes. So for example, let's say the area under this space is 5 and the area down here is 7. Okay, area itself is always positive, but integrals is signed. When I take an integral, I have positives and negatives. And let's say this is 0 and this is a and this is b. If I take the integral from 0 to a of f of x, I get 5. If I take the integral from a to b of f of x, then my area is not 7, it's negative 7. If I take the integral from 0 all the way to b, that's another property. I can add those parts up. So the integral from 0 to a is 5, from a to b is negative 7. So the integral from 0 all the way to b is a total of negative 2. This is 5, this is 7, but this is underneath the x-axis, so this area is negative, so the cumulative area is negative 2. Likewise, if I go backwards, if I take the integral from b to a, I always read lower to upper. So if I take the area or the integral from b to a, so now I'm going the opposite direction that I read, now any area underneath the x-axis is positive and any area above is negative. So now this becomes 7. That's your basic properties. The only other one that I think I'm missing is if I have the area of 5 times f of x from 0 to a, this can be written as 5 times the integral from 0 to a of f of x dx. Okay, that 5 as a constant multiplier can be taken out and multiplied at the end. So therefore, this would be 5 times the integral from 0 to a, which was also 5. Give me 25. Okay, so when I integrate one function added or subtracted from another, I can do the integral of one and add on the integral of the other, and so forth and so on. So try the Khan Academy. I don't think that there's any other big surprises there. And tomorrow we'll start with Riemann sums.